Hello. In this video we will see how to work with two RTLs at the same time. In MATLAB and also in different frameworks it's possible to work with more than one RTL at the same time. They will work in parallel. A possible application of this is to see a larger spectrum, adjacent or not, to sense different channels, and so on. Each RTL will have its own radio address, and this parameter will let us distinguish one RTL from the other. So you can, and you must, configure each RTL independently, setting to each one of them its own parameters. But now you will need to be more careful to not confuse one with the other. This is a picture where you can see one RTL working on a certain bandwidth around a center frequency and the other RTL working independently in another center frequency which is sound with its own bandwidth. But if we process both baseband signals in our PC, we will be able to have to work with both of them as if they were only one. This is the picture in the bottom. Okay, let's plug both RTLs into the laptop. Okay, and let's go to MATLAB and see if we have recognized both of them. This is the same command as we explained in module 2. Okay, we return to the SDR info an array of cells. Let's see each one of them. The first one, okay, generic RTL is this one, and let's see the second one. It's generic RTL OEM. Okay, in short we will call them the black RTL and the blue RTL. It will be easier for us. Okay, let's move on. If we want to change parameters or properties of each RTL, we need to address the RTL that we want to change its parameters. For example, if we want to change the center frequency of the first one and say that we want them to work at 433 megahertz, we need to say that its radio address is 1, the first parameter of this function, and that we want to change the center frequency to this value. We do it. And we see that the radio address 1 has changed its center frequency to 433 megahertz. That's what we wanted. Okay, let's do the same to the other RTL. I will turn this one to another frequency, in this case 223 megahertz, and I will maintain the sample rate. Okay, we see that radio address 0 is tuned to the 223 megahertz and the number 1 to 433. Okay, that's very important. The first parameter of this function, the SDR RTL receiver, it's the radio address. Okay, let's move to Simulink. Once we have turned and configured our RTL, then we will need to implement all the receiver and all the processing that we always do. So here we are only explaining how to deal with one RTL and the other one separately. Okay, as I said, let's move to Simulink. In Simulink, we will work with two boxes, two independent RTL boxes. Okay, let's launch a blank model. Okay, I have a very slow laptop. I will explain you in the slide. We will have two RTL boxes, and we will connect each one of them to a separate spectrum analyzer box. So we will be able to see the band around this frequency, the 433 megahertz, and also in a separate window the 223 megahertz band. You have this example in the 2RTLS X1 SLX file in the course repository. So here, let's see if it has started yet. Okay, we'll launch the library browser of Simulink. We do the search. We add the model we add the block to the model. Here is one of them. Okay, I will make the window a little bit bigger. Okay, so we have two boxes. Now we need to tell Simulink which box corresponds to which RTL. So we do double click. This will be radio address 1. Okay, and this will be radio address 0. To avoid mistakes, I will call this one blue, the blue RTL, and also this will be the black RTL. Okay, so let's tune also. We said that the blue RTL will be at 433 megahertz, and its sampling rate will be 2.4 megahertz. Okay, no frequency correction. Let's remove the automatic gain control. Okay. Okay, every parameter was all right. And here in the black one, we said 223 megahertz, no gain control, the same sampling rate. Okay, and now let's add the spectrum analyzer. Okay, here it is. We add to the model. We need both, one for each RTL. Okay. Okay, let's go to the model. We have both spectrum analyzers here. We need to link them to its corresponding RTL. And we'll see, okay, no errors. Okay, let's start with the remote control. You see in the figure of the bottom, you see the RTL, the signal that receives the RTL from the remote control. And also, if we switch on the walkie-talkie, you will see in the, okay, you see it here. Here it is. If I unplug, if I plug, you see the signal. And also, again, with the remote control, we can zoom here and we see the ASK signal. Okay, let's stop the simulation and move forward. Okay, so as this is a picture of what we have seen before. One of the RTLs is tuned to 433 megahertz and the other one to 223. Here, if we only connect the remote control, one RTL will receive something, this signal here, the figure in the left at the right of it, and no signal. The other RTL will receive no signal because it's tuned into another frequency. So in this video we have seen how to work with two RTL in parallel, in both MATLAB and Simulink. It's also possible to work with more than two, of course. You will need USB ports to plug the RTLs and also CPU power to work with them. Of course, the RTL, it's a low-cost device and it has some limitations. For example, this device is unable to have a clock input to synchronize with other RTLs. But what we can do, it's a low-cost device, as we said. Okay, that's it. Thank you for your attention.